Okay, so let's kind of pick up where we left off. We had set up parent functions, and remind me who was all absent. Actually, just Roman. Okay, so let's make sure. Let me push. So here's our sine and cosine functions we set up. How can I tell, like, which one's the sine and which one's the cosine? Go ahead, Esty.
It's like where it is on the, like, I don't know how to explain that line right there.
Okay, so at x equals 0, let's say that.
Yeah.
Which one starts at the midline and which one starts at its max or min?
The cosine starts at the max.
Good.
And the sine starts.
Your cosine will start at a max or a min, and then your sine will start from the midline. Okay? And we have 5 key points that we want you guys on all your graphs to get your full points on the test. You guys will have to have 5 key points, and that means your guys' x-axis needs to be labeled. So that's the only thing we left out of the lesson on Tuesday. Was I didn't really go through making sure you labeled the entire x-axis. We went through the max and min, we went through like midline and all that, and like the different transformations. So the 5 key points are this first one, and the reason why we realize this one starts at 0 is when you plug in 0, sine of 0, and you do our calculations. And we learned this with the unit circle. The online video isn't going to see what I write on the board right now, but oopsie. So right here, when we did sine of 0, that goes through the coordinate 1, 0, and we developed all these coordinates, plugging them in at first. Now after today though, or after that, once we set up the parent function, I think you guys are going to have a pattern. You're no longer going to take the time to plug them in. You can plug them in to check. Like if you're worried that you're right, you can always plug stuff in to check. But remember, these are in radians, so if you guys do want to check, you'd have to turn your calculator to radian. Those of you who want to check your coordinates and see if they are right. You would have to put it to radians. But let me do my little fake triangle. I'm over at 1, I'm over at 0. So when we did the sine of 0 degrees, it was opposite over hypotenuse, or y over r, and it was at 0. So that's why we know sines will start at the midline, because sine of 0 is 0. Cosine of 0, however, though, is 1 over 1. So it's up at 1, so it's up at the max instead of at the origin. So that's the difference of sine and cosine functions. For those of you who need that little recap and just a reminder, okay? So I'm going to go back to this little lesson right here. So we had set up these parent values. Your amplitude, remember, was your a. It was the number out in front of your function. How do we decide the midline? The midline is where the graph goes same amount above as it does below, okay? So that's midline. How did I determine my midline? So if we have an A here, that'll determine our amplitude. And then where's my midline? So here's A. What was the midline? Think of the midline line that runs like this, and what's the only transformation that will move something like that? Left and right. What's the coordinate? Or what's the part of the equation? The
y.
Yeah, we can be a little more specific, but yeah. The what shift will move my midline? Our vertical shift. And where is the vertical shift in the equation? Yep, it's like separate from the sine function. It's the plus and minus number, okay? So outside of the sign, if you guys ever have a plus or a minus of something, we called it the D in our notes because we had a lot of stuff going on in the notes. That was the up and down shift, right? What part in here affected our period length? Do you remember? It was whatever was connected to the x. Good. It was right here, and we usually put like the B right there. If you guys remember that transformation when we set up transformations, so we aren't going to do horizontal shifts today for you guys. We're only going to worry about that affecting our x's. So what happened when we put a B there? What did it do to some graphs? Do you guys remember when we learned transformations in general? So back when we did transformations and it was like, okay, these affect our vertical shift. Inside here affects my horizontal shift. Outside here is, vertical stretch, then vertical shift. And then this B, if we ever had a BX, do you guys remember that the X's lie and Y's tell the truth? And how that was the horizontal stretch or horizontal compression or stretch. And remember how x's lie and how you actually get to times by 1 over b to your x's. Do you guys remember that with general ones? But we weren't making you guys do a lot of the horizontal stretch and compress. So it's kind of an advanced type transformation, and we do it a lot more in the college classes. We do it a little less here in the regulars. And so that is the reason why, what part of the function did it affect, or what part of the formula did it affect, right here. What do? Your period is normally 2 pi, and you technically times it by 1 over b, so the b affects your guys' period. Okay, so our a, we always take the absolute value of it when you describe your amplitude. Even if it's a negative function, you always take the absolute value of it. Okay, period, you calculate it by doing 2 pi over b. Okay, the vertical shift will move your asymptote. And then if your number out front is negative, then it just switches. So a negative cosine would now start at a minimum. And then your negative sine, would now go down to a minimum instead of start up and head to a maximum. So that's the only difference with your sine cosine is it's like the x-axis reflections. Okay, so that's a good recap of what we talked about so far last time. So if we can get all those details and put them together, you guys are expected to label the rest of your guys' x-axis, okay? So let's go ahead and just talk about really fast. Does anybody need this slide? Rome, are you kind of caught up? So Roman, we also referred to, we go all the way around the unit circle, okay? And all the way around, and then things repeat themselves once you get to 2 pi. And so 1 period is 2 pi because it just repeats itself. So 1 period, sine of whatever, I can find sine of any angle between 0 and 2 pi. Any angle. But the easiest values we find are the halfway mark, and then half of that, and we label all of those. So whenever you guys want to label your x-axis, you take half of that, or you could take a fourth of the period, because you need to label every single tick mark. I need to label from here to here, and every one of these is the same size. So if this is 1 pi halves, I get to add another 2 pi halves, 3 pi halves, 4 pi halves. Does that make sense to everybody? So what do you guys think our strategy is? Get our period and then do what with it to label the rest of your axis? Once you know your period, we have those 4 little increments, right? So we can do what to get our x-axis labeled? How many of you would rather times by half and then times by half again to get that 4th mark? That could be you guys. Or you guys could take it in half. Sorry, take a 4th of the period to get that 1st mark. Okay? Let's decide what you guys like best. But that's how this is broken up. It's broken up into 4s. So we have 5 key points, and then it's broken up those 4 little intervals between those key points. That's what you guys need to be able to plot. Okay? All right, let's do it. Let's put it together. So I want to hurry and go back to this and see if we can figure this out a little bit. So I'm going to go ahead and put we used 4 last time, okay, for a sine function. And let me just zoom in just a titch, okay? So we had used a 4 in front of our b, and so 6.2 was the regular period for the original sine function. Like, let's compare this next. I like to compare it next to the original sine function, actually. So our original sine, the blue one, was this one. So compared to the original one, up and down and back up, and it ends at 2 pi. That was my original one without a 4. And now I can get through 1, 2, 3, 4 periods in the same time that as the original parent. And so to get through this one, you guys would have said 2 pi over 4. So let's see what those are labeled. I'm going to go right here to the red one. Let's take this one off. Okay, so here's my 5 key points that we want to be good at finding, and it's the x-axis that I care that you label. Okay? Okay, so there's 1 period. Okay, so what do you think half of pi halves is going to be? Pi fourths, because I just simply times by half. So that halfway mark is pi fourths. What's half of that? Pi eighths. Yeah, how are you? Good, how are you? Good. This is for pi 8. So what do you guys think, once I take half of that now, and it's going to be at pi 8ths. So I would label this pi 8ths. Then 2 pi 8ths is pi 4. So what do you think this one's going to be labeled, where this is? this minimum? What do you think it's going to be? 1 pi eighths, 2 pi eighths. So what do you think this is going to be? 3 pi eighths. Does that make sense? Okay, let's change it up for a couple and then we'll just graph a few. Let me do one that has a fraction. Okay, I'm going to do 1 over 2. Oops, bad. 1 over 2. And I'm going to put it back with the regular sine function for a second. So, 1 over 2, here is the 1 over 2. Okay, compared to the regular, or sorry, here's the regular parent function that got done by 2 pi. And then 1 over 2 is a little more drawn out. In fact, I have to zoom to try to see it. Okay, so take off the original sine function and let's get our 5 key points. Everybody with me? So we were able to calculate it. Let's calculate it together since the people at home can't see when I freeze the screen. Anybody who watches this video later. 2 pi over b, and my b is 1 over 2, right? So we learned that you would take 2 pi, and instead of divide by 1 over 2, we turn it to times by 2. So it kind of draws that period out longer. So if we click right here, I'm going to take this off. So our period is 4 pi. So we're going to go over here. We're going to click where this ended. And notice how it's at 4 pi. So let's get the increments. I can take half of it, and what's it going to be labeled as? 2 pi, and then half of that is going to be labeled as pi. Does that make sense how you're kind of breaking up? And then you get to count it. Pi, 2 pi. What do you think this is going to be? 3 pi, 4 pi. Now those of you who want to do the half and the half, great. You could also just take this and take a fourth of it to get that first tick mark, or that first increment. Okay, that's the strategy. Okay, let's go ahead and jump to trying a few. So we kind of ended with us filling in the details of some of these graphs we're going to do, because that's where we kind of like ended. And then I want to put them on an actual graph. But the end of your assignment has you graph 2 periods worth, and so I do need to make sure I graph 2 periods worth on one of these. Okay. Let's go ahead and jump to the first one. I'm going to zoom in a little bit. And we had calculated some things out. We had said the amplitude is, so these are the 5 things you're finding on the front page in different areas. Amplitude is 2. There's no b, so I get to say 2 pi over 1, or just 2 pi. Everybody with me? So if my amplitude is 2, and did our midline move? No, so it stayed at 0. So then when I do the max, you get to take your midline, and you get to add and subtract 2 from it to get your max and to get your min. So we're at y equals 2 and y equals negative 2. So everybody caught up with where we left off? So let's do this. Let's put this action on an actual graph, and then let's graph it. This one's easy because we didn't really change much from the parent. And I'm not going to make you guys do stuff to scale, but I am going to kind of like quickly sketch the parent compared to these ones. So I'm going to go 1, 2, 3, 4, and I'm going to write my period. Okay? And I'm also going to write in my max and my min. And we said our max was what? 2. And then what's my min? Negative 2. And then I'm also going to make note of where my midline fell. Sorry, we should have done midline then max and min. So far I have noted my amplitude and my max and mins and the midline. And then I've written in my period. So now this is a cosine function. So at 0, where is that going to be? If you guys, unless you're, if we're on our Chromebooks, we're either doing an assignment if we're on our Chromebooks. But if you're on your Chromebooks being distracted and doing things, that's not appropriate. Okay, so I need to be able to, what's happening at the starting point if it's a cosine?
Start off at 2.
It will. And this is a positive cosine, so I get to start up at 2. Okay, what should happen a fourth of the way? It should cross the midline. Good. What should happen half of the way on cosines? It should reach a minimum, right? And then what should happen 3/4 of the way? Cross it again, cross the midline, and then I should end right back up here. Now, you guys can do the easy part of your graphs so easy. If you do, and this goes on for forever, but we're not expecting you to. We just care for one period on most of the backside. But you will be deducted if you guys don't label those. So that's the difference. Okay, so you guys can graph this from all this easy piece of information, okay, the pieces of information. So then we're gonna take it in half, and since this one is a lot like the parent, it doesn't take hardly any calculations because it's so much like the parent, okay? And there's your graph. That's how easy it is. But let's do one that the period did change. I wanna do one that the period's gonna throw us off. And we're not gonna do a vertical shift yet, and I didn't change the amplitude on this one. Should I hurry change the amplitude on this one, or are you okay? Should we just worry about the period on this one? Okay, let's move to B then. Okay? And we're going to be doing some from your assignment in just a minute, I promise. We'll just kind of fill in the graph on these. I want some in your guys' notes so that you guys have, something to refer to. All right, let's go ahead and find all of our important pertinent information that we are going to do. So this is 2 pi over what? And let's label everything. Bless you, midline, our max, and our min, okay? We want all of these things labeled and thought about. Okay, what's this one's amplitude? 1. What's this one's period? 2 pi over, careful. So this one's labeled kind of like, because my program doesn't do equations very well, this is x over 5, which is the same thing as what is your b? Because this says x over 5. Same thing as saying 1 what?
1/5.
1/5. So this is the same thing as me saying 1/5 x also. Okay. So I get to divide by 1/5, which I take 2 pi and instead times it by 5 over 1. So when I times by 5 over 1, that makes my period actually 10 pi. We okay with that? Okay. So you divided by the b. Dividing by 1/5 is the same thing as timesing by 5 over 1. Cool? So whatever the b is, it literally goes right there in the formula. And treat 2 pi over b like it's a formula. So you're just putting that into the formula. Okay? All right, did our midline move? No. And then since I only have an amplitude of 1, I get to add a 1 and subtract a 1 from the midline. So I get to say that the max is 1 and that the min is -1. Okay? Awesome. Let's do our 5. Let's do our little 5 key points. So 1, knowing that it's more drawn out, I would love if you guys would kind of try to make it to scale. Because we're going to, remind me before I move on to the next question, to put the regular, just the period of 2 pi with this one so we can see the difference, okay? So you can make it just a relative to your graph every time as long as your x-axis is labeled. Okay, my max we said was up at 1. My min was at -1, okay? And then we said our period was 10 pi. Let's label the rest of it right now. What would you do?
5 pi is the half.
For sure the halfway mark is 5 pi. And then we get to take a half of that. And you could have also taken a fourth of that to start your first tick mark. But
So 2.5 pi, 7.5.
yeah, you leave this ratios. So if I times 5 pi by 1/2, so I'm going to go over here and do this little side math. Whenever you guys need to take half or a fourth of something, you just times it by it. And then just leave it as a fraction. So we're going to call this 5 pi halves. So let's count and make all of these 5 pi halves, then another 5 pi halves, then another 5 pi halves, then another 5 pi halves. So 5 pi halves plus another 5 pi halves was 10 pi halves, which is 5 pi. I'm at 10 pi halves, so now what? 15 pi halves. So these can be kind of ugly when they're not nice whole numbers, and then we get 20 pi halves. Does that make sense? So once you guys have this tick mark, you can label the rest. Make sense? Okay, put it together. It's a sine function, so see how I'm not making you plug anything in? It's like a pattern you're memorizing. So I told you it'd be easier to graph. Do sine functions start at the midline or start at a max or a min? They start at the midline, and then it's a positive function. So do I go up to a max next or do I go to a min next? I go up, so I'm going to go up to a max. What's going to happen halfway? Cross the midline. What's going to happen 3/4 of the way? Reaches a min, and then ends. You guys are expected to reach your maxes and mins and cross your midlines in the proper part on those 5 key points, and then you'll get your full function graph. I think on the test these graphs are like 5 points, so I want you guys to really have them, down. Okay. All right, now I want to show you in a bright green color, where would the parent function be done by? Before we drew it out to 10 pi, where did our parent function end? At about 2 pi. So this is 2.5 pi, if we were to put it into a number. So do you guys realize the parent function, when they're placed together on a graph, would have looked something like this?
Shorter.
Yeah. So even though we're drawing this relative to us just sketching it, if it was drawn with the parent, we would make that way more drawn out. Okay? I'm okay that you make it just relative to your graph, but I do think I want you guys to realize how they reference to the parent function. Everybody okay? Okay. All right, this one we had done, I think we did in class with you guys. This is the way I ended my 8th period, so let me know if we don't have this one already in your notes, but let's just go through the details, okay? I like this one because the midline moved. Oops, I'm gonna give myself a better graph. There. Come on. Is there a reason you're not working for me? Okay. All right, where did this one's midline move to?
3. Oh, wait.
Yep, we moved it up to y equals 2. So we're gonna go 1, 2, and we're gonna redraw our midline. This isn't mandatory, and it's not an asymptote, so don't think it's an asymptote. And you can erase midline after, but at least it helps you be able to go the above and below and know where it should cross, okay? So I love the midline being drawn just for that purpose. And then we know, we learn our amplitude as well on this one. 3. So where should my max and my min occur?
Max is 5.
We add 3 to the 2 and subtract 3 to the 2. So I think we ended with this one before the bell rang. And so we're up at 5 and we're down at -1. So we have all of our key, oh, we don't have our period labeled. So period is 2 pi over b, so what's this period? Still just what? 2 pi, and it's just like the parent function. So we already have those ones memorized, right? We know it's pi halves, pi, 3 pi halves. And so if the period doesn't change, you just gotta copy your parent function, okay? All right, this is where people have a struggle with graphing it because everybody wants to come below the x-axis, but we're going above and below the what?
Midline.
The midline, okay? So do sine functions start the midline or
Start that midline.
it should start the midline, then what?
Up to 5.
So I should be at pi halves 5. And then what should happen half of the way?
Back to the midline.
Back to the midline. So it's not the x-axis, but I'll see kids who do. I see kids who plot through there. So it's the midline we're referencing, okay?
And then down to -1.
It should reach -1 at 3 pi halves.
Back to the midline.
Back to the midline. Very good. So that's probably my number one mistake when the midline does move, is being able to realize that, okay? I want to do 2 periods worth on one of these. I don't know if I love, let's go up to this other one actually because it had such an ugly, not ugly, but I don't love how ugly that x-axis is, but it's good practice. So the last part of your assignment, because I think I just want to let you guys get to work. So last part of your assignment, let's do 2 periods worth on this one. So I'm going to have that be my starting point, and I'm going to go 1, 2, 3, 4 again. So 1 period was 10 pi, so what do you think 2 periods will
20
be?
pi.
Huh?
20 pi.
Yeah, 2 periods was, I'm just going to times that and just times by 2. Now you're going to continue counting with this size. 5 pi halves, 10 pi halves, 15 pi halves, 20 pi halves.
25
What goes
pi
here?
halves.
25 pi halves. What goes here?
15 pi.
30 pi halves, but yes, you're right, and you would actually write 15 pi instead. I would love it for it to be simplified. 30 pi halves, then what?
35 pi.
35 pi halves. So those of you who were hung up on maybe doing 2 periods worth, because I know some of you guys are trying to assignment, you just take whatever size that tick mark was and you just keep drawing in that length. So we just counted 5 pi halves, 10 pi halves, 15 pi halves, 20 pi halves, 25 pi halves, 30, and just keep counting through the next period. And then everything's just repetitive. I get to go to my max again, I get across the midline, I get to go to my minimum, and I get it end at the midline, and then I get to go like this, and I did 2 periods worth. So do you think you could extend 2 periods on yours? Okay, let's do a couple from your assignment, and then I'll just kind of let you work. I'll just stop talking, let you guys kind of get a big head start, hopefully, before your break, as far as math is concerned. Do you want me to pick one? Do you guys want to pick it? I would rather you guys do the 2 period ones because there's only 2 to practice. So I'm going to make you do those. But do you guys notice anything from 8-4 that looks exceptionally, has some stuff going on? I think 23 is a great one, but if you'd rather attempt it, that's great.
If you think 23 is great, let's do 23.
It's a good one just because it has a lot of information to find. And we have to change our x-axis and everything. It's a good one. So 23, if you guys want to follow along, okay? So your guys' is 23, I believe, tell me if I'm copying it wrong, but it's 6 cosine 8x. What is on it? Oh, plus 2. Okay. All right. So I need probably a lot of space in this. All right, all the important information. Let's do it. I need amplitude. I need period. I need if our midline moved, and if our what our new max and our new min are. And let's go. Start just span off the details and let's build this.
I'm gonna guess amplitude here is gonna be 6.
Yes, amplitude is 6.
Yeah. Midline maybe at 2.
Midline is going to be at y equals 2. Let's go ahead and draw that. Let's go 1, 2, and we're going to kind of just draw our imaginary. It's imaginary, so don't treat it like it's like, and even asymptotes are imaginary on those graphs we just did in the last unit.
Max at 8.
Or 2 units, they're imaginary. But okay, what did you say?
Max at 8.
Why did you say 8?
Because it's 2 plus 6.
Very good. So I go 2 plus the 6 puts me at y equals 8. So I'm going to go, I'm going to mark this at 8. That's my max. And then where's my min? Good. 2 minus 6 puts me at y equals -4. Perfect. We're only missing what? Period.
2 by 8 or
2 pi over 8. Yeah, when there's no fraction, that's the easiest one. Now, to make life easier, always simplify fractions. So that's actually going to be pi what? Pi over 4. So we're going to call period pi over 4. So when you guys are given a picture and we're supposed to pick out what the period is, you guys have to know where the period ends. So the ones that have pictures for you, you guys have to be like, oh, the period ends there, okay? So we're going to go 1, 2, 3, 4. And I only kept this really small because we're going to hurry and draw the parent compared to this one. Okay, let's label the rest of the x-axis, you guys. How do I get those other tick marks? That's times by 1/2, which is dividing by 2. So you're going to take your period, pi fourths, and times by 1/2 to cut it in half. So that's what? No, because we're timesing by 1/2. Pi 8. Good. So you guys, these need to get smaller. Pi 8 is cutting a pi into smaller pieces because there's more of them. So like the bigger the denominator gets, the smaller that size is getting, right? So it kind of feels weird that like that's a 4 and that's an 8, but it's because it's in the denominator. Let's take now, so now we're at pi 8, and let's take half of that. What's half of pi 8? Pi 16. So now we know what to count by. As soon as you guys get pi 16, now we count by it. Okay, 1 pi 16, 2 pi 16, 3 pi 16. Okay, we're all labeled. Perfect. I'm going to take it in red and do all of our 5 key points, and then we have it.
Start at 8.
Why do you start at 8?
Is it a cosine function?
It is a cosine function, and it's a positive cosine function. So we would start up at 8. So I'm going to be right here. Okay, what happens at pi 16ths? It should cross the midline.
Yep.
At pi 16ths, you should be crossing 2. What should happen at pi 8ths? It should reach a minimum, yeah? So that's down where? At -4. So we're down here at our minimum now. And then what do I do?
Back to the midline.
I cross the midline again the 3/4 of the way. So at 3 pi 16ths, I should be back up at 2, crossing the midline. And then what should happen at the end of the period? Back up to its max. Good. So cosines will start and end at the max or the min if it's a negative function. You guys got it? Okay. So put it together. Try to make these like smooth and rounded. We usually don't make them look like peaks or anything. I think, how many of you feel like you have it? Okay. So let's just try and talk about this. Let's double the period. I want to double that. Pi 4ths, if I double it and go 1, 2, 3, 4, and I times that by 2. No, if I times by 2, you said pi halves, right? We're still not even close to the parent function. So if this was with the parent function, we would have to like keep going quite a few periods because that was an 8. I would be able to get 8 of these in before I get to 2 pi. Isn't that crazy?
It's wild.
So if this was with the parent function, we would see the parent function like clear over here. We'd be able to get 8 of those in. Does that make sense? Okay, I'm going to be done. You guys are good to work. I'm going to try to go